Hello everyone. Welcome to this tutorial on interfacing a 7-segment display with PIC16F877A microcontroller. In this video, we will learn how to connect a 7-segment display, understand how it works, and write a program to display digits from 0 to 9. This tutorial is beginner friendly and very important for embedded systems and microcontroller projects. So let's start. What is a 7-segment display? This is the picture of a 7-segment display. A 7-segment display is an electronic display device used to show numbers from 0 to 9. It is made up of 7 small LEDs arranged in a figure of 8 pattern. Each LED is called a segment and is labeled from A to G. By turning specific segments on or off, we can form different digits. There is also an optional 8th LED called the decimal point, but in this tutorial, we will focus only on digits. Each numbers are formed using a unique combination of these 7 segments. There are two types of 7-segment display. They are common cathode and common anode. Common cathode means in common cathode display, all the cathode terminals of LEDs are connected together and tied to ground. As you see in the previous picture, here you can see the 7 segments A, B, C, D, E, F, G. The right side, that is all the cathode of the LEDs are connected, joined together and connected to ground. Okay, this type of connection is known as common cathode. Okay, this type of connection is known as common cathode. To on a segment, we have to apply a high signal from the microcontroller. So in the case of common cathode, to turn on a segment, we have to apply a high signal from the microcontroller. This means logic 1 turns on the segment and logic 0 turns off it. Okay, logic 1 turns on the segment and logic 0 turns off it. This tutorial uses the common cathode type. Now going to common anode, all the anode terminals are connected together and tied to VCC. In the case of common anode configuration, all the anode terminals, that is the positive terminals, are connected together and tied to VCC. To turn on a segment, we have to apply a low signal. In the case of common anode, to turn on a segment, we have to apply low signal. And to turn off a segment, you have to apply a logic 0. That is the opposite way of common cathode. It is very important to identify the correct type before connecting. If you use the wrong type, the display will not work properly. Now let's check how the segments are named. Each segment has an label. Here you can see the segment A, and segment A is the top horizontal line. Segment B is the upper right vertical line. Segment C is the lower right vertical line. Segment D is the bottom horizontal line. Segment E is the lower left vertical line. Segment F is the upper left vertical line. And segment G is the middle horizontal line. Understanding these positions is very important because we will control each segment using microcontroller pins. Now let's check how to connect a 7-segment display with PIC16F877A. We use Port B of microcontroller to connect these segments. RB0 is connected to segment A, RB1 is connected to segment B, RB2 is connected to segment C, RB3 is connected to segment D, RB4 is connected to segment E, RB5 is connected to segment F, and RB6 is connected to segment G. Each segment must be connected through a 220 ohm resistor. This resistor protects the LED from excess current. Okay, while you are using the hardware connection. The common cathode pin of the display is connected directly to the ground. Make sure all the connections are correct before powering the circuit. Now, how to display digits on a 7-segment display? To display digits, we send a specific binary or hexadecimal value to port B. Each value determines which segment will turn on. In common cathode display, logic 1 means on and logic 0 means off. So, for example, assume that I want to display 0. So, to display 0, we have to turn on the segment A, B, C, D, E and F. Okay. And you have to turn off the segment G. Clear? So, let's write the code. So starting from always the bit order starts from DP, G, F, E, D, C, B, A. So lower bit will be A and higher bit will be DP. Okay. So I'm starting from lower bit. For digit 0, A should be 1, B should be 1, C should be 1, D should be 1, E should be 1, F should be 1, but G should be 0 and decimal point we are not using, so it should be also 0. Okay, so how to write this? Yes, 0011 makes 3, right? 0011 is 3 and 1111 is F. So for writing 0 on LCD display, you have to use the hex code 0x3F. Okay, 0x3F means it will display 0. Okay, now if you want to display 1, okay, if you want to display 1, only B and C should be high. Rest of all the segments should be low. And if you want to display 2, A, B, G, E, D should be high and F and C should be low. Like that, you have to check the configuration of each digits. Okay. And you have to give the corresponding hexadecimal value. Is that clear? We understood that each digit from 0 to 9 has a unique code. These codes are stored in an array inside the program. Now, let's understand the program used to display. We understood that each digit from 0 to 9 has a unique code. These codes are stored in an array inside the program. Now, let's look how to do the programming for displaying the numbers from 0 to 9 on 7-segment display with 1 second delay. So let's start. First, as you know, you have to create a project, then the source file, then you have to set the configuration bit. And after setting the configuration bit, you have to give the frequency of the oscillator, that is frequency of the microcontroller that you are using. Okay, after creating the frequency, giving the We understood that each digit from 0 to 9 has a unique code. These codes are stored in an array inside the program. Now let's look how to do the code to now let's we have understood that each digit from 0 to 9 has a unique code. These codes are stored in an array inside the program. Now, let's look how to do the programming for displaying the digits from 0 to 9 with 1 second delay. So, let's start. So as you all know, first you have to set the configuration bits. After setting the configuration bits, you have to give the frequency of the microcontroller. Okay, and now as the next step, we are creating an array to store the hex code value of digits 0 to 9. Okay, so we will say an array as character. Okay, usually an array is considered as character. So the data type, you have to specify the data type of the array. That is why it's given unsigned character digits of 10. Okay, unsigned character digits of 10. Digits is the name of the array, and in the square bracket it's shown 10. 10 is the size of the array or number of elements in the array. Since we have to store the hex code of 0 to 9, we have 10 elements, hence the size of the array is 10. Is that clear? Now we have to assign the values to the array. For that you have to use curly brackets. Using curly brackets, you have to give the elements to the array, and each element should be separated by comma. Okay, after that, you have to write the main program. That is, first you have to set the port that you're using. Here, we are connecting the 7 segment display to port B. So, you have to set port B as output. That is why it's given tris B is equal to 0x00. After that, you have to create a continuous loop. So, we have used while of 1. And inside while you have to write the code to print the numbers from 0 to 9. For that, I have used a loop known as for loop. For counting 0 to 1, 0 to 9, I have used a loop known as for loop. Okay. So using this for loop, it will take values from 0 to 9. Okay, that is I is equal to 0. So it starts from 0. Then this loop will work till the value of I is less than 10. Okay, that is up to 9, the loop will work. Once the value is 10, the loop will stop and the programs again starts from the first value. Okay. So inside for loop, the code that is written is to read the value from the array and print it on the 7 segment display. Okay, and each digit will be displayed for 1 second because a delay of 1 second is given over here. Is that clear? Okay, now we will check the hardware connection and the simulation of this project. So this is the circuit for interfacing 7 segment display with 16F877A microcontroller. So the components required are PIC16F877A, crystal for crystal oscillator, capacitor for crystal oscillator, and the 7 segment display. Okay, so to take 7 segment display, keep the cursor here and click on, and right click over it and click on pick from libraries. After that, search for 7 segment display. You can filter it from here, clicking on 7 segment displays. So you can see all the displays over here. From this, you have to select common cathode 1 digit 7 segment display. So it is 7SEG MPX1CC display. So click over it and add it to the components list. Okay. Now, as usual, you have to connect the crystal oscillator. You have to connect the VCC to MCLR, and then to RB0 to RB7. From RB0 to RB7, the data lines are connected. That is A, B, C, D, E, F, G, and DP is connected to RB0 to RB7 respectively. And the common cathode pin is connected to ground. The one pin that is uh, shown here separately is the common cathode pin that should be connected to GND. Okay. Now we can program the microcontroller. For that, I'm going to copy the hex code from MPLabX. Here I have already done the program. So I have already explained it in the previous session. That is, you have to set the configuration bit, then the crystal oscillator frequency, then the array, and inside void main you have to write the main program to print the numbers from 0 to 1. Okay, so I'm going to build it. We have to click on build main project, then only you will get the hex code. Okay, so hex code is got. So copy the hex code. Copy the path for the hex code and paste it in the file. Okay. We have to paste it on the program file. So I have pasted it. Now click on OK. Okay. Now you can click on the run button and you can see it is printing from 0 to 9. Okay. After reaching 9, it again starts from 0. Okay, so after 9, it again started from 0. So this is the working of the interfacing of a 7-segment display with a microcontroller. Okay. So with this, I'm concluding the video. In our video, we have learned how a 7-segment display works, how to connect it with PIC16F877A, and how to write the program to display digits. This is a fundamental concept in the embedded system and a great starting point for many projects. So thank you for watching and keep experimenting and building.